Happy Friday, gals and guys. We made it through another week once again, and now we're only a few more days away from your AP Calculus exam. And I know you guys have been working so hard these past few weeks. As a result of that, I'm really confident that you are indeed going to disintegrate that AP Calculus exam next week. And I'm so confident that I believe that this year is going to be your grade on that exam. And on my video on Monday, my last video before your exam, I'll reveal what the score actually is, but hopefully you can calculate it before then. So I just want to do a few housekeeping items before we get started with today's material. And the first thing I wanted to do was I know that several of you watch the College Board YouTube videos to help with your preparation for the AP exam, and I actually listen to them as well. I think both Tony and Brian are doing an amazing job helping all students get prepared for the AP exam. And so, I'll listen to them whether perhaps eating lunch or dinner or even doing my morning stretches. And today, I was quarterback and actually somewhat surprised and really touched that I guess one of you tweeted Tony and Brian about a little shout out to Mr. Ambrose, and I just wanted to thank whoever that was that did that. I really was touched by it, and it definitely made my day yesterday on Thursday. Again, really, really, really touched by it, and thank you so much. So now for some general announcements to get you guys ready for your AP exam. First thing is that I know your exam is next Tuesday, 1:30 p.m., and I'm sure there's going to be a lot of nerves and anxiousness between now and then. So on Monday and Tuesday, I would like to give dedicated extra help sessions on those 2 days prior and leading up to your AP exam. And so I'd ask that you please fill out the Google form to try to get a sense of when you might want to have those sessions. I believe I can have 10 people at most in any one session, but I would have multiple sessions on those 2 days to try and accommodate anyone that would like an extra help session before your exam. I will also be posting two actual exams, a BC question and a BC1 question and a BC2 question. These were made up by Tony and Brian. Again, giving you more practice. So if you want to have time practice on your own over the weekend, you can do those. And I will post my solutions so you can check them. And then the other thing is that as you do them, perhaps what you might want to do is after you do them, practice the uploading of them to the AP demo site. I definitely think you should try to, upload things more than once, so that when it comes time for your actual exam, the uploading of your work is going to be second nature, and that's not something you have to be worried about on your exam because you're going to be worried about so many other different things. And then the other thing is that I will also post is sample questions that the College Board themselves have actually posted. So this is the sample questions that the College Board posted for the AP Calculus BC exam this year. And when I looked at this, and again, this will be posted so you can look at it as well. When I looked at this here, this looked exactly like the questions that I've been receiving from Tony and Brian that I've been forwarded and posted on Google Classroom for you guys to try out yourselves. So, right, we see here a graph and we see some questions that, again, these are very similar to what I've been assigning to you guys. And then we have another graph and some other questions really similar to what you guys have been doing over these past several weeks. So if you have been doing those questions, you should feel really comfortable that you're heading in the right track. Now, these questions here, when I looked at them, what the College Board did was they just took parts of free response questions from the 2019 exam and they actually placed them in here. So if you try these out, you may recognize them if you already did the 2019 free response questions. But that's the structure that they say your exam will look like. And then they go on to say here that you may want to look at free response question number 4 and free response question number 5 from the 2019 AP exam. I'm not going to go back and look at those again with you guys, only because this free response question number 4 was related rates, which I've talked about already, as well as a separable differential equation, which I did just the other day. And then free response question number 5 was an integration problem where you had to integrate by using partial fractions, which I know it's been a little bit of a while, but I did go over that with you guys. You can look at those questions again, but I don't want to do that in this video today. Instead, they also say that you may want to look at free response question number 1 from the 2019 exam, and that is what we call refer to as a rate in, rate out problem, and that's what I'm going to focus in with today's video. But before I actually get to that rate in, rate out problem, there's one other announcement that I want to make. I've been wanting to give you this for a while now, but because of the adjustments in the AP exam, I've had to adjust this thing. And this is something that I give to my students every single year. And I'm happy to say that it's going to be posted today. It's going to be ready. And you guys are going to be able to refer to it as you make your final preparations for your AP exam. So it's finally here. So what's finally here is the Holy Bible, what some students will refer to as the thing to refer to help ultimately with their AP exam. And so this is a version from prior years. It has pretty much everything that you've learned during the year, but this is a succinct place to perhaps see everything that you learned and perhaps can help you with ultimately referring to when you're taking your exam to quickly remind yourself about something that you have to apply in a particular question. So this will be posted and ready for you guys on Friday. So I hope that this will help you in your final preparations for your AP exam. Okay, so now let's look at this rate in, rate out problem. So here we have BC question number 1, and we're told the function f is continuous on the interval from 0 to 10 and consists of 3 line segments and a quarter circle as shown in the graph above. The table above gives values of g and its derivative g prime at selected values of t, where g is an increase in differentiable function on the interval from 0 to 10. Dear enter quorum at a rate modeled by the function g, and dear leave quorum at a rate modeled by the function f. Both g and f are measured in dear per year, and t is measured in years since Mr. Ambrose moved into his home. Right, because I live in Quorum, and in Quorum, we have deer frequently visiting us at various times during the day. So this deer here was outside my front window when I woke up and opened the blinds to the front of my house and gave me a nice little greeting there. I think he was just as surprised as I was. Anyway, at time t equals 0, the number of deer in Quorum is 28. So now in part A, we're asked how many deer leave quorum from time of 0 to time of 8. So again, this is called considered a rate in, rate out problem because we are told that the function g is the rate at which deer enter quorum. And then the function f is another rate of how deer leave quorum. And so it's a rate. We have 2 rates, a rate of how deer entering and a rate how deer are leaving. And remember that when you hear the word rate in any of these problems, you should be thinking pretty much that that is already a derivative. Okay, so we have here the functions g and f, which are different rates. So to determine how many deer leave quorum, just how many actually leave quorum, I claim that we're going to have to integrate the function f because f is the rate at which deer are leaving quorum. And specifically, if we just want the amount of deer that leave quorum, we would want to set up, or we could set up a definite integral starting at 0, going up to 8. And this definite integral here should tell us the total amount of deer that leave quorum over this time interval. And remember that a definite integral, we can evaluate that geometrically because that is equal to the area between our graph and the x-axis, and specifically from 0 to 8. So to help out with calculating the area of all this region, I'm going to break this up into a quarter circle and a rectangle and 2 triangles. So now the area of this quarter circle, it's 1/4 pi times the radius of that quarter circle, which is 3 squared. The area of a rectangle is a 4 by 6 rectangle, so we can just take 6 and multiply that by 4. Get the area of that rectangle. And then this triangle here has base 3, height of 3, so that should be equal to 1/2 3 times 3. And then the last triangle here has base of 2 and height of 4, so the area of that triangle there would be 1/2 2 times 4. And we don't have to simplify this answer here because these are all just numbers being multiplied and added up together. You can punch that into a calculator. So this here would be a satisfactory answer for how many deer leave quorum on this time interval. So now let's look at part B to the same BC1 question. And in part B, we are asked, is the rate of change in the number of deer increasing or decreasing at time of 9? And to do this, we have to be really, really careful, because to determine if the rate of change in just the number of deer itself is increasing, well, we'll want to look at the derivative of this rate of change function. But we have to be careful. We have two different rates here. We have one rate which is telling us how deer is entering quorum, and another rate at which is telling us how deer is leaving quorum. So I claim that those two rates, we kind of have to look in tandem to help ultimately answer this particular problem. But to get a better grasp on things and how things are all set up, I'm going to label A of t to be the number of deer in quorum. That's just the total number of deer that are in quorum. And then if we derive that, we should get the rate of change in the number of deer in quorum. And I claim that this derivative here is equal to our function g minus our function f, because the difference between the rates of how deer enter in and then leave in quorum should tell us exactly how the overall rate of deer is changing in quorum. And now to determine whether this rate here is increasing or decreasing, right? Whenever we want to determine when any function is increasing or decreasing, we have to look at its derivative. So that means that we're going to want to take this rate and derive it. So we will want to get the second derivative of this original function here, which would be equivalent to g prime of t minus f prime of t. And if we want to determine if this rate of change is increasing or decreasing at time of 9, we'll just want to evaluate this particular derivative at 9. So this should be equal to g prime of 9 minus f prime of 9. And now g prime of 9 we can get from our table. That's just 1/4. F prime of 9, we can evaluate that off of the graph of f, because f prime should be equal to the slope of the tangent line to the graph of f at 9. And the slope of this line segment here is 1. And this is -3/4, which is less than 0. So because the derivative of our rate of change is negative, that means that this rate of change is decreasing at time of 9. Okay, so the last question that I would like to go over with you guys is still on the same BC1 problem at part C. So here we asked at what time t for this particular closed interval is the number of deer in quorum at a minimum. Justify our answer. So we see here we're basically asked to find a minimum on a closed interval, and pretty much all the time that you're asked to do that, you would want to construct that table that I pleaded with you to try to do whenever you have a closed interval. And in this table, we would want to include our endpoints, but we would also want to perhaps plug in here any critical values to the derivative of this function a of t. And that function a of t, right, if we derive that function a of t, right, as I showed you in the last problem, that should be equivalent to the difference in the rates and these rates of change. So we can set this equal to 0 and then try and solve for exactly, when this is going to be true. But this will be true when g of t essentially is equal to f of t. And so we have to now try and figure out, well, how can we actually do that? We have here the function f, which is nice and continuous. and has all positive values. But for G, right, we only have snapshot data here. But there was one thing that was stated in this problem that is key, and that is that G is increasing throughout this interval. So that means it's always going to be getting larger. And so because of that, the rate of F starts off at a value of 4, whereas G starts off at 0. And both of our rates technically increase up until 3. But then after that point in time, the rate for F is decreasing. And so if we look perhaps at a time of 6, the rate of F is 4, but here at 6, the rate of G is 8. So there has to be, because G is differentiable, thus it's continuous, there has to be some value before 6 where G and F are going to be equal. And if we look at time of 5, I claim that at time of 5, F's rate, S value is 5 as well as G's. And that is the time at which these two are going to be equivalent, and that is our critical value. But now here's the problem that we're going to have with trying to find out what these values are here. We were told that the beginning number of deer in quorum is 28, but while we can find antiderivatives for the function f, we really can't do that for the function g. So how could we possibly figure out what the minimum value is? And I claim that the fact that we only have one critical value here, we could do something else that we talked about this year to help us ultimately figure out whether there is a minimum, an absolute minimum at this point. So what we can now do is we can first try to see, do we have a relative minimum at this point? And I hope that you would agree that since the values for the rate of f before 5 are greater than the values for the rate of g before 5, that this difference is going to have to be negative before 5. But then after 5, since g just continues to increase and get larger, but f's values are getting smaller, that this difference will change to be positive. So based upon this here, what we can say, just based upon this here, we can say that there's a relative minimum at t equals to 5 since a prime changes from negative to positive, right? Because whenever we see a respective derivative change in signs, in this case negative to positive, we know we have a relative minimum. But now, since this is the only relative extrema, we can further conclude now that this must be an absolute minimum. Okay, so now I'll write this down and I'll say that since this is the only relative extrema, and I say extrema and not minimum, there is an absolute minimum at t equals to 5, right? Because the idea here is that with this particular justification is that this was a minimum, not a maximum, and so we have this situation here going on, right? With there being only this relative minimum and no other relative maximum on either side here, this has to be an absolute minimum, and that's why this justification of first establishing the relative minimum and then say that it's the only relative extrema, right? There's no other relative maximum. It has to be an absolute minimum. Okay, so I hope that this video helped you understand the nuances of a rate in, rate out problem. I'll list some other rate in, rate out problems that you could perhaps look at in prior year's free response questions, but keep in mind those are going to most likely require a calculator. So the problem that I constructed here is perhaps how they may give you this type of a question. and I will post my question because there's more parts to it, and you can try them out, and my solutions will be there for you. And just quick reminders, the quiz I posted last Friday is due today as well, and that's a quiz, as well as the mock AP exam numbers 1 and 2 as a homework assignment. Those are due today. And then on Tuesday, I posted this other mock AP exam where you just had to show me the picture of you successfully uploading that to the AP demo site. And that's an optional assignment. But if you do that right, you can receive full credit provided you show me your picture. And so, again, please also just, and there's a lot, but try to complete the Google form, and I'll set up extra help sessions next Monday and Tuesday. And then you have these other questions here and other things that you can practice over the weekend to get final preparations for your AP exam. So I hope all this helps. Please keep sending any questions if you have any. And as always, well, enjoy your weekend and take care, stay safe, and I'll talk to you soon.